in this completing the square, and maybe you remember completing the square, maybe you don't. I kind of wrote some steps out here for you, like a formula, and then steps with it. If you kind of remember already and you have your own way to remember, you don't necessarily have to write this down. If you've been really bad at completing the square, I would suggest writing this down. There is a question on your quiz that says solve by completing the square. So if you do the quadratic formula, you're not going to get your points on it because they want you to complete the square on it. Okay? So the whole idea of completing the square is we want to make this a perfect square trinomial, right? Like x plus something squared equals a number. Because if we have that, then we can do that square root property that we did yesterday. So that's what it means by completing the square. So do you remember what we do first on this? If this was my problem and I wanted to complete the square, what would I do? Yeah, this makes it not a perfect square, so we just shift that over to the other side. So I just subtracted c over. You could write that out. Move c to other side. What if it recognizes my move c to other side? Oh, look at it. And then the big step for completing the square is, what do you do to this number to figure out what we're going to add here to complete the square? You remember? How to complete the square? What do? You take half of that middle number and you square it, because if you take and you square a binomial, it's always half of that middle number squared. So I wrote it, oh look, move C to the other side. I guess I did that underneath it. You take half of b and you square it. So I wrote that as plus b over 2 squared. If you'd rather have words, I said take half of b and square it. Add this to both sides, right? You can't just add it over here. You have to add it to the other side also. This is honestly where the quadratic formula comes from. If we worked this out with ax squared plus bx plus c and we did completing the square, what we'd end up with is the quadratic formula. So that's where the quadratic formula comes from. Someone didn't just sit around one day and think, oh, this is going to work, like it came from completing the square. So then this is the big step. Like, to me, if you know that, you know how to complete the square. From there, it's just cleaning it up. So from there, you want to factor this, right? You want to make it that perfect square. So every time that should factor into x plus that b over 2 quantity squared, and we'll do one with real numbers in a minute. And I just still have the other side not simplified, because how do I add those together? And so my last step is now solve for x using the square root property. Factor and solve for x using the square root property. So I think half of the middle number and square it is kind of like the key idea with completing the square. And again, you might say, well, I like quadratic formula better. It always works. That's true. But on the test, they make you do completing the square. And there are certain times in math, like if you're trying to write a conic section in a certain form, or you're trying to write a quadratic in vertex form, you have to complete the square. Like quadratic formula doesn't work. So that's why it's an important skill to have. All right, so let's look at a couple examples together. One nice one, maybe one not so nice one. Okay, I'm going to go on this one and stop. All right, let's start with this one. Oh, I guess that's still not so nice, but that's okay. A nice problem to complete the square on would be one that has nothing in front of x squared, because it does get uglier if there's a number in front of x squared. Also, if the middle number is even, it's a lot nicer, because half of an even number is not a fraction or a decimal, right? But I picked one that's not so nice, because if we can do this, you can do the nice ones a lot better, okay? So following my steps. Step 1 is this 3 does not make a perfect square, so we're going to move that 3 to the other side. I don't know how you did it in algebra 2, but for me, when I do that, I always leave a space here to fill it in, and I'm going to leave leave the same space on the other side to remind myself whatever I put here, I also have to add here. And again, I know you guys like decimals, probably because your calculators do decimals, but fractions just work out so much nicer. And why do I like fractions over decimals? I can do that in my head a lot easier with fractions than with decimals. So I just want to show you how you can do this and you don't even really need a calculator. Because I'm going to take half of this middle number and I'm going to square it. And yes, 5 as a decimal, take half of it, 2.5, easy to know. But really nice as a fraction, if you take half of something, you just put it over 2, right? If you have a decimal and then you have to square it, probably most of you don't know what those decimals are squared off the top of your head. Maybe 2.5 squared you do. But if it was like 19 halves, do you know what that is squared? 9.5 squared. Maybe you do, maybe you don't. I'm not really good at doing decimals in my head. But I'm really good at squaring fractions in my head because all I have to do is square the top number and square the bottom number. So I know I'm going to add 25 over 4 to both sides. Right? So I don't just try to make you use fractions because I think that you have to. I think you should use fractions because it's easier to do with fractions. All right, so that's the big part. Half of the middle number squared. Make sure you do it to both sides. So now, what do I do over here? Every time, the whole idea is we completed the square, we made it a perfect square. Every time that should factor into something squared. I don't even think about it because I know it's going to factor into x minus 5 halves. Whatever that middle number was that we took half of it, that's always what it's going to factor into. And you can check. Negative 5 halves times negative 5 halves gives me 25 fourths, and negative 5 halves plus negative 5 halves gives me negative 5 in the middle. But you shouldn't have to think about that. Like, it just always works out that way. Over here, yes, you can use a calculator if you need to. If you don't know, your calculator will give you improper fractions, or if you don't know how to use fractions, please ask me. It's a really good skill to know how to do fractions on your calculator. But again, I'm just going to show you that it's not bad to do without a calculator either. Common denominator, multiply by 4, so that would be negative 12 fourths. Negative 12 plus 25 is 13 fourths. What is this? I think it didn't. I think someone threw this at me. We're going to go through and check whose pencil this fits on. Brandon, did you throw this at me?
I tried to throw in the trash can.
So don't lie to me then. Like, start out with, sorry, I tried to throw the trash can instead of me thinking that you're throwing it at me.
You looked at your marker, so I just went with it.
You think I was going to pick it up and realize it wasn't part of my marker?
That's what I was hoping.
What do I do from here? Find a new job, maybe.
I have another study on.
Oh yeah, you have to do 2 of these. Maybe just do something like this. Did you believe that? Let's just run that.
I'm gonna make it so it's going to fail again.
It's handwritten, that makes it nice. Alright, yeah.
It don't work out right.
You can have a, I think it should be okay without. Let me know.
Wait. Oh, okay.
Okay. What do I do to solve this? This is like what you should have done on your homework yesterday, right? What do you do when you have a perfect square equal a number? Square root it. So if I get x minus 5 halves equals plus or minus, again, works out really nice because the square root of 13 is just going to stay the square root of 13, and the square root of 4 is 2. If you did decimals, you would have an ugly decimal under a square root right now. Last step, get x by itself. I'll write it up here. I would get 5 halves plus or minus the square root of 13 halves. Not 12. it would look like if we do the quadratic formula as well. We would get answers like that. If this was a 4 instead of a 5, it's so much nicer because half of 4 is 2 and 2 squared is 4 and we don't have to think about fractions. But it's okay to have to do fractions. You get a scientific calculator, which means you can even do the fractions on your calculator and it would do those for you. And if you don't know how to get improper fractions without a calculator or with a calculator, let me know and I can help you do that as well. Let's do an even ugly one. What makes number 2 different than number 1? Trevor. You cannot complete the square if there's a number in front of x squared. You have to get rid of it. So what do you do to get rid of it? Divide everything by 4. And I'm going to go ahead and add that 3/4 over to the other side. That's 0. So then that's just going to be 3/4 over there. You okay with that? What is half of 1/4? 1/8. Half is just like multiplying by a half. So over the side here, 1/4 times 1/2. It's just 1/8. And what do we get when we square 1/8? 1/64. Again, your calculator will do all that work for you. If you just take 1/4 divided by 2, it'll still give you 1/8. It's the same as multiply by 1/2. Again, I don't think all the ones in your homework are as ugly as this, but if we do the ugly ones together, hopefully that makes the ones on your homework easier, as opposed to us only doing nice ones and then all the ones on your homework being awful. Right? Half the middle number and square it. What am I going to write here? X, what? Plus, because if the middle number is plus, that's plus. Over there, the middle number was minus, so it was minus. And what do I put there? Half of that middle number. That's why I wrote it there. 1/8. Last time, half of the middle number was 5/2. We can't be scared of fractions. Fractions are our friends. Or our calculators can do the fraction for us. 3/4 plus 64? 4 times what gives me 64? 4 times 16? No? True? So 16 times 3 is 48. You guys just make me 48/64. Is that the same as 3/4? Sometimes I think I'm doing all the work, which could be why, if I'm doing all the work, that sometimes your grade doesn't turn out so well, because I just do all the work up here, and then when you have to do the test, and you're used to me doing all the work, and you're like, oh no, why did I do it on the test? You have to do the work too. Let me know if we're doing it right. Tell me if you have questions as we're going through it. Because if I'm just doing all the work, it's going to be really hard for you to know whether or not you need help from me. Look how nice this one turns out. You might think that's not a very nice answer, but what do you notice about 49/64? That's a perfect square for a perfect square. Oh my gosh. Square root, x plus 1/8 equals plus or minus 7/8. I think this means we could have factored this problem. I said solve by completing the square. So if I subtract 1/8, here's what I want you to know. Whether it's a quadratic formula or whether it's completing the square, if what you get here is a perfect square number, I expect you to give me both answers. Like, don't leave it as 1/8 plus or minus 7/8 or whatever. Like, work it out. Give me the two answers. So we have 7/8 minus 1/8, right? That would be the positive root. And we have negative 7/8 minus 1/8, because you have to do the plus and the minus. So what's that give me? 6/8, which is 3/4. And here I get negative 9/8. Negative, just kidding, 7 minus 1 is negative 8/8. Negative 8/8, which is just negative 1. 2 real nice answers, even with fractions. Okay, we can do fractions, we can do that. I know you can. Even if you don't want to, you can. Okay, most people are not fans of completing the square, especially when I make you do awful problems like that. Remember that we also have the quadratic formula, and that's what people said yesterday. Hopefully you have this memorized. You will never get this formula given to you. You want me to sing the song to you?
Yeah.
Sing the song to you. So it goes to do your ears hang low, this is a Barney song, but also known as do your chain hang low, apparently. I don't know that song. I'm too unhip for that. Is unhip a word? Alright, ready? Due to A hang low under negative B plus or minus square root B squared minus 4AC. If you practice your quadratic, you will learn it automatic. Due to A hang low. I think I did that wrong. But I do it again. Due to A hang low under negative B plus or minus square root B squared minus 4AC. If you practice your quadratic, you will know it automatic. Due to A hang low. All together now. I always say all together now, and no one ever has sang along with me except for Brandon Gerke. So, there's also a Pop Goes Weasel one that's not as cool. So.
Go ahead and do that one too.
X equals negative B plus or minus radical B squared minus 4AC all over 2A. There's also one to the Notre Dame fight song, but I don't know that one. But Mr. Mulis always sang that one. You have to call him to get into it. You just gotta know what A, B, and C are. Set it equal to 0. Plug it in, right? Remember that we can talk about this idea of a discriminant. That's this part. Based on the discriminant, you should be able to tell me what kind of roots am I going to have. If you don't know the rules for the discriminant, you just solve it out and look at the roots to see what they are. But it is in your book, and I wrote them on here as well. Remember that if what's under the radical is positive, so if you get a positive number greater than 0, then you're going to get 2 real roots, just like we just did. We got like negative 1 and 3/4. 2 real roots. So it's going to cross like this. It's going to have 2 solutions. If what's under the radical equals 0, then the plus or minus goes away, and you're just left with negative b over 2a, which means you get that 1 real double root like we got yesterday. That means the vertex is touching the x-axis. And then what if what's under the discriminant is negative? That means you don't have any real roots, but you learned last year in Algebra 2, that means you have complex solutions. You have imaginary numbers, which we'll talk about the next section. That means your parabola does not touch the x-axis. So either the vertex is above and it opens up, or the vertex is below and it opens down. And so as we get into graphing and all that stuff later, stuff will come back. But I always say if you don't know the rules, you just work it all out and then you tell me what the answers are based on what you're looking at. So we better practice this once, right? Maybe twice. People like the quadratic formula because if you know the formula, it takes away the thinking part, right? You don't have to remember the rules for completing the square. You just plug it in and simplify it. But people make mistakes doing that. So make sure you show me some work on that. So let's do an example. How's it going back there, Katie? Did my song help you any? There's a YouTube video of 2 guys singing that. They're much cooler than me, and it goes on after that. If there's time, there's probably not time. We have lots to do still. Okay, let's do it. I think number 3 we're gonna do together, and then number 4 I think I made go formative for you to do. Look, there's your code. Maybe. But number 3, let's do this one right now. So don't do number 4 yet. I'm going to cover it up. What do you think we should do first on number 3? Yeah, simplify it. Get it in that format. Ax squared plus bx plus c equals 0. So we would get 6x minus 2x squared equals 3. My advice is put it in order, A, B, C, right? So x squared is first, then x, then the constant. So I'm going to rearrange this and make this negative 2x squared plus 6x, and then I'm going to subtract that 3 over, right? I can't just move it over, I have to subtract it over. If you don't have it equal to 0, then you don't have the right A, B, and C. So now we know A is the number in front of x squared, B is here, C is here, and you just have to plug it in. Feel free to hum along the song as you're writing it if you want. Negative B plus or minus B squared minus 4AC all over 2A. It's not exciting when you're not singing it. All over 2A. That's why the Papa Smoke Weasel is nice. My advice, show me some work here, right? If you show me that step and then you have the wrong answer, at least I know you had the right formula. At least I know you put the numbers in the right spot, even if you made a mistake later. I always say if you're not sure, like just type that all in your calculator. 6 squared minus 4 times negative 2 times negative 3. I'm going to do a little work here. 8 times negative 3 is negative 24. Is that true? And for some reason, some people don't like to put it all over 2A. All over 2A. Not just part over 2A. What's 36 minus 24? 12. With me to there? Ready with me to this point? Let's have a chat now about simplifying our answers. You cannot simplify something under a radical with something in the denominator. So it is not okay to say, well, I can divide everything by 2 here, right? It's not allowed. But what I should do is, if I can take a perfect square out of this, if I can simplify that radical, we have to do that. And we can simplify 12 as the square root of 4 times 3. So we can write that as negative 6 plus or minus 2 radical 3 all over negative 4. Can I simplify more than that? Yes is the right answer. And you can do this a couple ways, right? So I'm going to give you 2 ways to do this. The way that I've always done it is look at the denominator and look at the numbers in the numerator. If they're all have a common factor, if they're all divisible by a certain number, then you can divide them all by that. And in this, do you agree that they're all divisible by 2? Which means I can say that's the same as saying negative 3 plus or minus square root of 3, because 2 divided by 2 is 1, all over negative 2. I'm only allowed to do that because it was divisible by all of them. Lots of people make mistakes like this. In pre-calculus, it's probably the most missed problem on our first test is making mistakes simplifying this. So here's my other way to simplify this. If you're like, I don't really know how you got that, you can break this up as 2 fractions, and then you won't have to worry about, am I allowed to do it or am I not allowed to do it? This is the same as saying negative 6 over negative 4 plus or minus 2 radical 3 over negative 4, which the negative 4 kind of seems silly when you have plus or minus there, right? If you're unsure, am I allowed to do this? If you break it up, you can simplify each one separately. So negative 6 over negative 4 is just 3 halves. Plus or minus, what do you do with that negative 4? Because it's plus or minus, you just leave it. Radical 3 over 2. Because the minus, right? Do you leave the negative 2 on the bottom? I think we should leave it. Because the plus or minus of this, and then we would still, oh, I don't even know. That's weird. I'm kind of unsure about that. Okay. We're going to talk more about this simplifying thing. It even talks in your book. It says, remember, I'm not allowed to do this because people make mistakes with this. is what you're saying? Want me to sing the song again? Alright. So you want to do another one? How many more do I have? I have a story problem after this. Alright. You should try this one. It's really cool. If you go to Go Formative and you enter this code in and have this question on there, you could type in your answer, or if you just want to do it on your paper, you can do that too. But I want you to do the quadratic formula, which means you might need a calculator. These are some big numbers. Anybody want me to throw a calculator at them? Oh my gosh, Taylor.
What are you doing? Broke up. I still made one this kind of.
Did someone pick up the one that I threw? Oh. Just because I throw calculators at you doesn't mean you're allowed to throw back at me, alright? Let's make sure we make that clear. I think that's the code. My geometry class, I made a class for them, and they all joined. They weren't in whoever's class. Janet's class. I don't know. What? Because you're going to do this project, and I thought if you need a visual, it's great to make your own stories. Oh, project, an activity. Maybe make a poster thing. We'll see how far it is. I want to remind you that when you put negatives in your calculator and you square them, if you don't put them in parentheses, your calculator gives you the wrong answer, right? So for me, even though this was a negative 30, when I write this down here, I always just write the positive because I know when I square it, it's going to be positive anyway. But if I didn't, if you're going to write the negative there, you have to put that in parentheses, at least on my calculators you do, because otherwise it gives you negative 900 as the answer and 900 is the answer. What are you getting cool things to happen? Should I check the board?
So can I go back and look over it?
Yeah.
Have you had a
Yeah. Apparently I don't read correctly. Sorry, my fault. I think that there's a. I don't even know. I have to look for that.
Are you sure?
Does it start with the equation for free fall?
Yeah. There should be no graph.
No, it's graphing calculator. Hold on, bring it. What is the back? How many questions are there? Yeah, that's right. Yeah. Yeah. Yeah, this is a calculus. This is another graph calculator. Sorry. Oh my gosh, why is this not? I just want this. PVCQ999.
You got a line for
I was just there, but I think what should happen is this should go to 0. If you didn't get 0 under your radical, you need to check to see what happened. But this should equal 900 minus 900. So this is an example when you should just have one answer. So you're just left with 30 over 18. And then you just want to simplify that, right? You could divide those both by, and you would get 5 over 3. So that's one double real root, which also means this was factorable if you did that. If you get a nice answer, it means it was factorable. Questions on how I got 5/3? You can leave them. Go ahead and sign off on that, and then shut them, and I got one more example here, okay? And you don't have to write every word of this down. Just hit down at the bottom by your... Over here, if you just click over here. And you can just close them, and you can leave them, and we'll put them up later. The last thing that you need to know from this section is how to do some story problems, mostly talking about position. If you take a physics class, you talk about this a lot. In calculus, we talk about this a lot. It says the height above ground in feet of a toy rocket t seconds after it's launched is given by this. If you want the short version of this on your notes, I would just write this equation. You could even say h equals height, t equals time in seconds, right? So you could say h equals height, t equals time. Right, it tells you all that. That's why you kind of need the words to go with it. This is a quadratic, right? So if you throw an object, right? This is talking about launching an object. But if I took this pin and I threw it, it's going to make a parabola. Even if I just throw it straight up, it's still going to have that turning point. And it's going to come down and make a really skinny parabola. So this position function will give you a parabola shape every time. So they like to give you problems like this, and there's definitely physics and calculus stuff that goes right along with this. But you just need to know what this is asking you. When will the rocket be 180 feet above ground? Should I plug that 180 feet in for h, or should I plug that in for t? H, that's height, right? So you're going to set up your problem. 180 equals negative 16 t squared plus 120t. That's a quadratic. I like to keep my t squared positive, so I'm going to move everything to this side. And I'm going to make that 16t squared minus 120t plus 180. And if it asks me, when is that true, that means I'm looking for time, right? So now I just need to solve this. Yes, sir. What? It's minus 180? No, it's plus 180 because I moved everything to the other side. Right? But yes, if you move the 180 to the other, like, depends on which way you move stuff. Sometimes these are factorable, and if you wanted to try to simplify it and make things nicer, we can. I was trying to figure out if I could divide through by a number and at least make my number smaller. But if you have a calculator, like, you can always just do the quadratic formula. Do you agree with that? We could also complete the square here if you wanted to. 16 doesn't really divide into that very nicely. Let me just do the quadratic formula really quick. Don't leave if the bell rings. I'm holding hostage. Do you have to go back to study hall? What are you doing? I know, but don't you have to go to your next class? Well, does she know you're going to stay here again? Alright, just hold on. The velocity. All right, can I just tell you the answer to this?
Yeah.
Since we're talking about time, do you agree that this is a time, give it time? This is a time that a decimal makes more sense than an ugly answer? So like this would be a time that if you work this out, you should get 15 plus or minus 3 radical 5 over 4. But that's an awfully weird answer to give as time, right? So this would be when you type that in your calculator and you get 2 answers. So really quickly, don't leave because there's homework, all right? Why are there 2 times that the height is 180 feet? It's a parabola, right? So it's hitting it twice, going up and coming back down. There's one like this on your homework. I'm sure we'll talk about it. Guaranteed there's going to be one like that on the unit test because they made sure that we did this one. Make sure you write that down. It's really short. 27 through 39 multiple to 3 and 59. You can leave your Chromebooks. Just drop your calculators off as you go back through. Have a lovely day. Whew, that was exhausting.
I just want students to be office please. I need Dartina Newdeck,
Remind me,
Ryan
Sarah, I'll show you
Newman,
the
Sarah
song.
Watson, Sarah Parker, the junior Logan Taylor, the office please.